What are JSON Web Tokens? Why are they so popular? And how to use them? Let's find out. JSON Web Tokens, or JWTs, define a compact and self-contained way for securely transmitting information as JSON objects. This information can be verified and trusted because it is digitally signed. JSON Web Tokens are actually defined as an open standard in RFC 7519. This is how a typical JSON Web Token looks like. Each token consists of three parts: header, payload, and signature. In the header, there is information about the signing algorithm that is used when creating the signature. JWTs can be signed with a secret using HMAC or with a public-private key pair. The payload is the place where JWT claims are set. Claims are statements about the entity. There are some predefined claims that are not mandatory but are recommended, like the token subject, the issuer of the token, and the token expiration time. Additional data can also be set as custom token claims. The signature is applied on the base64 URL encoded header and the base64 URL encoded payload, using the algorithm that is specified in the token header. And this is our final token. It consists of three parts divided by dot: the base64 URL encoded header, the base64 URL encoded payload, and the base64 URL encoded signature. But what is the point of using base64 URL encoded data? Well, it can be easily used in HTTP requests between parties. And what is the difference between using HMAC, for example in HS256 signing algorithm, and using a public-private key pair for creating the signature with RS256 algorithm? Well, HS256 is a symmetric algorithm. That is why the same key is used to create the JSON Web Token signature and to verify that signature. RS256 is an example of an asymmetric algorithm, and it uses a private key to sign the JWT and a public key to verify the signature. The JWTs signed with symmetric algorithms have their disadvantages. When using symmetric algorithm, all the parties need to know the shared secret. When the number of involved parties grows, it becomes more and more difficult to guard the safety of the secret and to replace it. Another problem with symmetric signing is the proof who actually signed the token. When using asymmetric keys, you are sure that the JWT was signed by whoever is in possession of the private key. In case of symmetric signing, any party that has access to the secret can also issue signed tokens. But let's focus on the more practical solution that uses asymmetric keys and to illustrate how that works. We need RSA public-private key pair for the signing. Let's create the private key. We should then extract the public key from the private key. Now we can construct our JWT token. We start with the header. We use base64 to encode the header and then tr command to replace the plus and slash sign with minus and underscore respectively. Then we again use tr to remove the equal sign. This converts the encoded string from base64 to base64 URL encoded. Going to the JWT payload, we can set an exp claim that points to the token expiration time. And then we construct the payload. The signature is calculated on the header and payload, concatenated by dot symbol, using our previously generated private key. Now we have our JSON Web Token generated. Let's verify it by using our public key. The verification is successful. The identity of the token is verified. It is signed using our trusted private key. And the data placed in the token is not tampered with. Going back to the token structure, how a common JSON Web Token payload looks like. We have an issuer claim that specifies who has issued the token. A subject can be specified. This is typically the user that the token is issued for. The audience claim specifies the recipient of the JWT. The EXP claim specifies the expiration time in Unix time format. The issueAt claim specifies the time the token is issued. Also, some custom claims can be set. And how is typically a JSON Web Token obtained? The client authenticates against the authentication server. After successful authentication, a JWT is created and returned to the client. The client uses this JWT to access a protected resource in the application server. Be aware that secret information should not be placed in the token, as the token itself is exposed to the user and can be easily decoded. It cannot be modified though, as the modification will render the token signature invalid. And how is the client authentication done? Whenever the client wants to access a protected resource, the user agent should send the JWT, typically in the authorization HTTP header, using the bearer schema. But in the end, why should we use JSON Web Tokens? There is no need to store the JWTs in a database in order to be possible to validate them. JWTs have all the information stored inside, which includes the expiration time. The expiration time can be easily verified in the application server. After all, it is just a claim that is set in the token. The JSON Web Token verification is done only with a public key. No additional calls to authentication server are needed. This makes it quite a scalable and decoupled solution, as the public key can be cached in the application server. Multiple public keys can be exposed for validation. This allows easier rotation of the used public-private key pair. The JWT token header can have a key ID field that specifies which of the exposed public keys should be used for validation. It's just that the auth-rotated public key should be available for signature validation for a longer period of time than the JSON Web Token expiration time. Lastly, the JWT is quite flexible as it can be easily enriched with custom claims depending on your application and requirements. And that's it.